In this video, we are looking at the notes over section 12J, and we're specifically looking at modeling periodic functions. And we did example 1 in class on Wednesday, and I promised that I would post videos for example 2 and 3. So in this first video, we're just going to do example 2. So in the first problem, notice that you were given the equation and then you had to answer some questions about that. In this one, you're given the graph, you have to come up with the equation, and then you'll be answered some questions about that. So just like we practiced in class quite a bit, or we went over quite a bit on Wednesday, coming up with the equation for a graph, remember that when you have a sinusoidal graph like this one, the amplitude, the period, and the vertical shift, it doesn't matter whether you're writing a sine function or a cosine function, those values are going to be the same. So if you want, you can just kind of start out and find those particular values. So it says Ben is a fisherman, and he has this boat in Ryle Harbor. I'm not sure if I'm pronouncing that correctly or not. And it says this is part of the graph of the depth of the water at the mouth of the harbor. So we can see that on the independent variable, the horizontal axis, we have hours after midnight. So H stands for hours. And then on the vertical axis, we have the dependent variable, the depth of the water at the mouth of the harbor, and that's in meters. So the amplitude, remember, is calculated by using the formula. It's the maximum function value minus the minimum function value divided by 2. So in this case, the maximum function value is going to be at 8. The minimum is at 2. And so 8 minus 2 divided by 2 gives us 3. So we know that the amplitude is 3. The period of the function, remember, is the horizontal length that it takes to go through one cycle. And remember, it doesn't matter which cycle you choose, the period's going to be the same. And so you want to pick something that's easy. So it looks like if I go from peak to peak, high to high, that's pretty easy to see. Yes, that's one cycle. And then if I continue on, that's going to be a second cycle and so forth. So this horizontal distance goes from 16 down to, well, from 4 up to 16. So the period is going to be 16 minus 4, which is 12. All right, then the vertical shift, for that one, remember the vertical shift corresponds to D, and D is the value that's right in the middle between the high and the low. So in other words, it's the average. So it's going to be the maximum plus the minimum divided by 2. So that's going to be 8 plus 2 divided by 2, which is 10 divided by 2, which is 5. So, like I said, it doesn't matter whether you're doing sine or cosine, those values will stay the same. The horizontal shift does depend on what kind of a function you're going to write, and this says to model this as a cosine function. So if we're going to model it as a cosine function, then I think that this little piece that we just chose is a pretty good choice. Starting here, coming down and going up like this, because the original cosine graph, the one period that we use for the parent function looks like that. So we have all of the values that we need. We can see that this is a right side up cosine graph, and so when we choose our value for A, we know the amplitude is 3, and we know that that coefficient is going to be positive A. And by the way, what we're trying to fill in here is y equals A cosine of B times the quantity x minus c plus D. So if we're writing the equation, we know so far we're going to have y is equal to positive 3 times the cosine of b. Now remember, to come up with the value for b, we use the formula that b is equal to 2 pi divided by the period. And we just said that the period is 12, and so this will be 2 pi divided by 12, which is pi divided by 6. So that's what goes in for b. And then the C we're still going to find, that's the horizontal shift that we haven't found yet, plus D, which we know is 5. So we know that this is going to be X, and then either plus or minus, depending on which way we shifted. But remember, the way I told you to do this was to, first of all, find that principal axis, and we know the principal axis is where the value of D is, so that's at 5. So the principal axis is coming across here, and like I said, that is at 5. And then we want to draw a vertical line through the starting point of the period of the cycle that we chose. And this is the cycle that we chose starting here. So we want to draw a vertical line through that. Right? We want to find the ordered pair that goes with that point. So that point, we went over 4 and we went up 5, all right, because we know that this is the line y equals 5. So this is the point 4,5. So remember that this is the image of the origin. The origin used to be here, and it moved over here 4 and up 5. So what that tells us is that the vertical shift is 5, so that's why we have the plus 5, and the horizontal shift is 4 to the right, and so that means that we need an x minus 4. And I would encourage you, just like we did in class, to substitute this into your calculator and graph it and make sure that it matches the graph that we have up here. And then remember that this is one of infinitely many equations that you could come up with. You might come up with a sine function, or you might come up with another cosine function. So I would encourage you to play with that a little bit and see what you can do with that. All right, for F, it says calculate the depth of the water at 9:30 a.m. So remember that H stands for the hours after midnight. So at 9:30 a.m., what we're talking about is that H is equal to, actually I have X in here, and we're supposed to write it in terms of M and H. So the height, or the hours after midnight, sorry, is H. And then the height in meters is M. So I'll put that in there. All right, so H then is going to be 9.5, all right, because 9:30 a.m. is 9.5 hours after midnight. So what we want to do, let me come down here below, for E, then is take this equation, M is equal to 3 times the cosine of pi over 6 times, and I'm substituting 9.5 in for H, so I have 9.5 minus 4, and then plus 5. And you can put that into your calculator, and you're going to end up with 2.102, which is approximately 210 meters, 2.10 meters. So that's the answer for F. All right, then it says in the last part, Ben's boat can only get in and out of the harbor when there is at least 4 meters of water at the mouth of the harbor. And then Ben sleeps until 10 a.m. So it says find the next time that he can go fishing. So essentially what you want to look for is so let's set this up, is where is the water 4 meters deep? So we want this to be 4. So we're solving the equation. 4 is equal to 3 cosine of pi over 6 times the quantity 9.5 minus 4. You could go ahead and subtract that, plus 5. Oops, I'm sorry, not 9.5. We want the x back in there again. We want the general equation. So what you can do then is on your calculator, and I demonstrated this for one of the problems in class on Wednesday, is put the 4 in as one function and this in as your other function. So this would be the function y equals 4 on your calculator. You look for the intersection, and you should find that these intersect at 12.3509 ... 4, all right, which makes sense because we wanted the height to be 4. Now, notice that this actually intersects at several places. If you look at this graph right here, let's use a different color. If I draw the line at 4, you can see it crosses once, crosses twice, and then crosses a third time, and then again. But remember, he doesn't get up until 10 a.m. So this is 10 a.m. right here. So these two that are right here, he's not up yet, so he can't use those. So the first one that we want is this one, which you can see is a little beyond 12. And so if you, this keeps freezing, I'm not sure why. If you use the intersect feature on your calculator, then you're going to come up with this answer. Now, if you wanted a time, remember that this stands for 12.3509 ... hours. And if you want to actually change it into clock time, then we know that it's going to be 12 hours plus 0.3509 hours, but 0.3509 hours, if we multiply that by 60 minutes in 1 hour, then these will divide out, and when you take the 0.350 times 60, you're going to end up with, let me multiply that, so 0.3509 times 60 or so, you end up with about 21 minutes. This should be 09. So you end up with about 21 minutes. So that means that the clock time would be 12:21 p.m., right? Because it's afternoon. And that is it for example 2.